The exploration of Venus represents one of the most fascinating and challenging chapters in humanity's quest to understand our solar system. From early telescopic observations to the sophisticated missions of the modern era, Venus has been a focal point of scientific inquiry. Despite its proximity to Earth, Venus remains one of the most enigmatic planets in our solar system, largely due to the extreme conditions that have made it so difficult to study. In this video, we'll explore the history of Venus exploration, tracing the evolution of our understanding of this planet and highlighting some of the key missions that have shaped our knowledge. Howdy, I'm just some random nude dude sitting in my closet talking to myself. It's also where I celebrate the power of free thinking and encourage bold ideas. As a society, we're often afraid to challenge the norms or think outside the box. But here, I embrace the unconventional. So sit back, relax, and join me on this journey of exploration, where we embrace our inner nude dude and push boundaries to discover new perspectives. Welcome to the third installment on my series on Terraforming Venus, where I delve into the rich history and ongoing efforts to explore this mysterious planet. Venus, often referred to as Earth's sister planet or Earth's twin, has captivated the imagination of astronomers and scientists for centuries. Its bright, unblinking presence in the night sky and its enigmatic shroud of clouds have made it a subject of fascination and study since ancient times. However, it wasn't until the advent of modern space exploration that we began to uncover the true nature of Venus, a world both eerily similar to and profoundly different from our own. In this video, we'll journey through the milestones of Venus exploration, starting with the early observations that first sparked humanity's curiosity about our neighboring planet. We'll explore how ancient cultures viewed Venus and how early telescopic observations in the early 17th and 18th centuries began to reveal its intriguing mysteries. These initial glimpses laid the groundwork for the scientific quests that followed, leading us into an era of space exploration. Then we'll transition to the 20th century, where the space age ushered in a new chapter of our understanding of Venus. The Soviet Union and the United States embarked on a series of pioneering missions that would forever change our perception of the planet. From the Soviet Venera program, which achieved the first successful landings on Venus, to NASA's Mariner and Pioneer missions, which provided the first close-up images and data, we'll examine how these early missions set the stage for more advanced explorations. As technology advanced, so did our ability to explore Venus in greater detail. The Magellan mission in the 1990s marked a significant leap forward, using radar to map the planet's surface with unprecedented clarity. This mission unveiled the complex geology of Venus, revealing vast plains, towering mountains, and enigmatic volcanic structures. We'll discuss how Magellan's findings deepened our understanding of Venus's geological history and its implications for future exploration. Finally, we'll bring the story to the present day, highlighting the recent and ongoing missions that are reigniting interest in Venus. With new discoveries about the planet's atmosphere and surface, along with the potential for groundbreaking future missions, Venus is once again at the forefront of planetary science. We'll explore the goals of these missions, the technological advancements that are making them possible, and what they could mean for our future understanding of Venus and its potential for habitability. Throughout this video, we'll not only reflect on the achievements of past missions, but also consider what lies ahead in the exploration of Venus. As we continue to push the boundaries of space exploration, Venus remains a key target for scientific inquiry and a potential candidate for future human exploration and even terraforming. Join me as we embark on this journey through time, uncovering the history and ongoing story of humanity's quest to explore the enigmatic world of Venus. Venus has captivated human imagination for millennia. As the brightest object in the night sky after the moon, Venus was known to ancient civilizations and was often associated with various deities. The ancient Greeks identified Venus as both the morning star, Phosphorus, and the evening star, Hesperus, unaware that these two distinct appearances were in fact the same planet. With the advent of the telescope in the 17th century, astronomers began to observe Venus in greater detail. Galileo's observations of Venus in 1610 were groundbreaking. He discovered that Venus exhibited phases similar to those of the Moon, which provided crucial evidence for the heliocentric model of the solar system. This discovery was a pivotal moment in the history of astronomy, as it challenged the geocentric view that had dominated Western thought for centuries. Despite these early observations, Venus remained shrouded in mystery. Its thick cloud cover made it impossible to observe its surface directly, leading to wild speculation about what lay beneath the clouds. Some early scientists even imagined Venus as a lush tropical paradise, a stark contrast to the harsh reality that would later be revealed. The story of Venus begins long before the advent of modern science. Rooted deeply in the mythologies and observations of ancient civilizations. Venus, the brightest object in the night sky after the moon, has fascinated humanity for thousands of years. Its consistent and striking presence in both the morning and evening skies made it a significant celestial object for early astronomers and a central figure in various cultural narratives. In ancient times, Venus was often associated with deities and was imbued with spiritual significance. The Babylonians referred to Venus as Ishtar, the goddess of love, fertility, and war. Similarly, the ancient Greeks identified Venus with their goddess of love, Aphrodite, a connection that was later adopted by the Romans, who named the planet after their goddess, Venus. This dual nature of Venus, as both a bringer of life and a harbinger of destruction, mirrors the duality seen in the appearances of both the morning star and the evening star. Mayans also paid close attention to Venus, incorporating its movements into their complex calendar systems. They viewed Venus as a celestial warrior and timed certain military campaigns to coincide with its position in the sky. The importance of Venus in these cultures highlights the planet's role not just as an astronomical object, but as a powerful symbol embedded in the spiritual and daily lives of early civilizations. The mystique of Venus continued into the Renaissance, when the invention of the telescope allowed astronomers to observe the planet in greater detail. In 1610, Galileo, using one of the earliest telescopes, made a discovery that would challenge the prevailing geocentric view of the universe. He observed that Venus exhibited a full set of phases, similar to those of the Moon, which provided crucial evidence that Venus orbited the Sun, not the Earth. This observation was instrumental in supporting the heliocentric model proposed by Copernicus, which placed the Sun, rather than the Earth, at the center of the solar system. Galileo's observations of Venus marked a turning point in astronomy. They demonstrated that the Ptolemaic model of the universe, which had dominated Western thought for over 1,000 years, was incorrect. The phases of Venus could only be explained if Venus orbited the Sun, thus reinforcing the Copernican system. This was a revolutionary shift in human understanding of the cosmos, placing the Earth as one of several planets orbiting the Sun. However, despite these advances, Venus remained an enigma. The planet's surface was entirely obscured by thick clouds, leading to widespread speculation about what might lie beneath. Some early scientists imagined Venus as a lush tropical world, possibly covered with oceans and teeming with life. These speculations were fueled by the fact that Venus is similar in size and composition to Earth, leading to the assumption that it might also have similar conditions. Throughout the 18th and 19th centuries, as telescopic technology improved, astronomers continued to study Venus, but the planet's thick cloud cover prevented any direct observation of its surface. This lack of direct evidence allowed for a wide range of speculative theories about Venus's nature. In the early 18th century, a famous astronomer, William Herschel, hypothesized that Venus might have a thick atmosphere, possibly even with water clouds, suggesting that the planet could be a fertile, water-rich world. This idea persisted well into the 20th century, with some scientists proposing that Venus might be covered in vast oceans or swamps, possibly supporting a rich ecosystem of plants and even primitive animals. The notion of a tropical Venus was further fueled by the belief that, because Venus was closer to the Sun, it was likely warmer than Earth, and boy is it. Early 20th century science fiction writers often depicted Venus as a hot, steamy world filled with exotic plant life and mysterious creatures. These imaginative portrayals were the product of a limited knowledge of the time, but they also reflected humanity's deep desire to find life beyond Earth. This period of speculation highlighted the limitations of Earth-based observations. Despite its brightness and proximity, Venus remained an elusive target for astronomers. The inability to see through its cloud cover meant that Venus was, in many ways, a blank canvas, onto which both scientists and writers could project their ideas and fantasies. As the 19th century gave way to the 20th, the study of Venus began to shift from pure speculation to more rigorous scientific inquiry. Advances in spectroscopy allowed astronomers to analyze the composition of Venus's atmosphere, revealing that it was dominated by carbon dioxide. However, these findings were still not enough to dispel the romanticized view of Venus as a potentially habitable world. It wasn't until the mid-20th century, with the advent of space exploration, that humanity would begin to uncover the true nature of Venus. The early space missions, particularly those conducted by the Soviet Union's Venera program and NASA's Mariner missions, would shatter the idyllic vision of Venus and reveal a planet that was far more hostile and alien than anyone had imagined. The early observations and enduring mystique of Venus played a crucial role in driving the exploration of the planet. The allure of Venus, both as a scientific puzzle and a symbol of potential otherworldly life, has been a powerful motivator for centuries. Even as our understanding of Venus has evolved, the planet continues to captivate our imagination, representing both the promise and the peril of exploring worlds beyond our own. The dawn of the space age in the mid-20th century marked a new era of exploration for Venus. With the development of rocket technology, it became possible to send spacecraft to study Venus up close. The Soviet Union took the lead in this effort, launching a series of missions under the Venera program. This ambitious project aimed to explore Venus's atmosphere and surface, despite the extreme conditions that were only partially understood at the time. The early Venera missions laid the groundwork for what would become one of the most successful planetary exploration programs in history. The first attempt, Venera 1, was launched in 1961. Although it was a bold effort, the mission was ultimately unsuccessful. Contact was lost with the spacecraft before it could send back any data. However, this failure did not deter Soviet scientists. They continued to refine their technology and approach, leading to Venera 3 in 1965, which became the first human-made object to impact another planet, though it too failed to transmit any data before crashing in to Venus's surface. The breakthrough came with Venera 4 in 1967, which successfully entered Venus's atmosphere and transmitted data back to Earth. This mission marked a historic achievement as it was the first spacecraft to return direct measurements of another planet's atmosphere. Venera 4 revealed that Venus's atmosphere was composed predominantly of carbon dioxide with only trace amounts of nitrogen, and it confirmed the presence of a thick cloud layer. These findings were significant, as they began to paint a picture of Venus as a planet vastly different from Earth, shattering earlier notions of Venus as a potential Earth-like world. Building on this success, the Soviet Union continued with their Venera program, launching a series of increasingly sophisticated missions. Venera 7, launched in 1970, became the first spacecraft to land on Venus and transmit data back to Earth. Although the spacecraft was only able to send data for 23 minutes before succumbing to the intense heat and pressure, it provided the first direct measurements of Venus's surface conditions, revealing temperatures of around 475 degrees Celsius and atmospheric pressures 90 times greater than those on Earth. The Venera program reached its zenith in the 1970s and 80s with the Venera 9 and 10 missions, which sent back the first images of Venus's surface. These grainy black and white images showed a rocky, barren landscape under a hazy, cloud-filled sky, offering humanity's first glimpse of another planet's surface. Venera 13 and 14, launched in 1981, provided even more detailed images and analysis of surface composition. They confirmed that the surface rocks were primarily basaltic, similar to those found on Earth, and they further solidified the view of Venus as an inhospitable volcanic world. The Venera missions were monumental achievements, especially considering the technological limitations of the time. The extreme conditions on Venus, with surface temperatures hot enough to melt lead and crushing atmospheric pressures, meant that each spacecraft had only a limited lifespan on the surface, typically just a few hours. Despite these challenges, the data returned by the Venera missions greatly expanded our understanding of Venus and demonstrated the feasibility of landing on and studying one of the most hostile environments in the solar system. While the Soviet Union was pioneering the exploration of Venus, NASA was also making significant contributions. The Mariner program, which initially focused on Mars, included 2 missions to Venus, Mariner 2 and Mariner 5. Mariner 2, launched in 1962, became the first successful mission to fly by another planet, gathering crucial data about Venus's atmosphere and surface conditions. In 1978, NASA launched the Pioneer Venus project, consisting of 2 spacecraft, Pioneer Venus Orbiter and Pioneer Venus Multiprobe. The orbiter provided a detailed map of Venus's surface using radar, which was necessary due to the planet's thick cloud cover. The multiprobe, on the other hand, released several small probes into the atmosphere, each designed to study different layers of Venus's dense clouds. These missions offered a comprehensive view of Venus's atmosphere and helped to confirm that the planet's surface was incredibly hot and dry, with temperatures hot enough to melt lead. The data from these 2 missions also suggested that Venus's atmosphere was composed predominantly of carbon dioxide with clouds of sulfuric acid, a finding that further differentiated Venus from Earth and shattered any remaining illusions about it being a sister planet in the classical sense. As the Soviet Union advanced with its Venera program, the United States was simultaneously pursuing its own exploration of Venus through NASA's Mariner and Pioneer missions. These missions marked the earliest and most important steps in humanity's quest to understand Venus. They were pivotal in shaping our modern view of the planet, revealing its true nature as a harsh and inhospitable world. Through these missions, NASA not only contributed to the growing body of knowledge about Venus, but also established critical methodologies and technologies that would influence planetary exploration for decades to come. The Mariner program was NASA's initial foray into interplanetary exploration, with the primary goal of sending spacecraft to explore Venus and Mars. Mariner 2, launched on August 27, 1962, was a landmark mission in the history of space exploration. It was the first successful spacecraft to fly by another planet and return scientific data to Earth, marking a significant achievement for NASA and the United States. Mariner 2's journey to Venus took approximately 109 days. On December 14, 1962, the spacecraft passed within 34,700 kilometers of Venus, collecting a wealth of data about the planet's atmosphere and surface conditions. The mission's most groundbreaking discovery was the confirmation of Venus's extreme surface temperatures. Prior to Mariner 2, there had been much speculation about Venus's climate, with some hoping that it might be similar to Earth's. Mariner 2 dispelled these hopes by measuring temperatures around 425 degrees Celsius, far too hot for any form of life as we know it. In addition to temperature data, Mariner 2 made several other critical observations. The spacecraft detected that Venus's atmosphere was composed mostly of carbon dioxide, with a very high surface pressure, estimated to be about 90 times that of Earth. This data provided early evidence of the intense greenhouse effects that trapped heat on Venus, leading to its scorching surface temperatures. Moreover, Mariner 2 also observed that Venus had no detectable magnetic field, a stark contrast to Earth. This suggested that Venus did not have a significant magnetosphere to protect it from solar radiation, further contributing to the planet's extreme environmental conditions. The spacecraft also gathered valuable data on the solar wind and interplanetary space, making Mariner 2 not just a Venus mission, but a pioneer in the broader study of the solar system. The success of Mariner 2 was a major milestone for NASA and set the stage for future planetary exploration. The mission demonstrated that it was possible to send a spacecraft to another planet, collect data, and return that information to Earth. It also provided a foundation of knowledge about Venus that would be built upon by subsequent missions. Following the success of Mariner 2, NASA continued its exploration of Venus with the Mariner 5 mission. Launched on June 14, 1967, the day a friend of mine was born. Hi, Mary Beth. Mariner 5 was originally designed as a backup for the Mariner 4 Mars mission. When Mariner 4 succeeded, Mariner 5 was repurposed for a flyby of Venus, providing a new opportunity to gather more detailed data about the planet. Mariner 5's mission objectives were similar to those of Mariner 2, but with more advanced instruments and a focus on redefining our understanding of Venus's atmosphere and space environment. The spacecraft passed within 4,000 kilometers of Venus on October 19, 1967, significantly closer than Mariner 2's flyby. This allowed Mariner 5 to collect more precise measurements of Venus's atmospheric pressure, temperature, and composition. One of the key findings of Mariner 5 was the confirmation of the high density and pressure of Venus's atmosphere, which was found to be about 90 times that of Earth. The mission also provided more detailed data on the planet's temperature profile, confirming the extreme heat that Mariner 2 had detected. Additionally, Mariner 5's instruments measured the planet's ionosphere and provided further evidence that Venus lacked a significant magnetic field. Mariner 5 also contributed to our understanding of the solar wind and the interaction between Venus's atmosphere and solar radiation. The spacecraft detected strong bow shocks, similar to those observed around Earth, indicating that Venus's atmosphere interacted with the solar wind in ways that were more complex than previously thought. This finding hinted at the dynamic processes occurring in Venus's upper atmosphere and its interaction with the space environment. The data from Mariner 5 not only expanded our knowledge of Venus, but also confirmed and refined the findings of Mariner 2. Together, these missions established a clearer picture of Venus as a world of extremes, a planet with an extremely dense and hot atmosphere, devoid of a protective magnetic field, and with a surface environment that was far more hostile than any previously imagined. The success of the Mariner missions underscored NASA's growing capability in planetary exploration and set the stage for even more ambitious missions. The Pioneer Venus project, launched in 1978, represented a significant leap forward in our understanding of Venus. This mission was one of NASA's most ambitious planetary exploration efforts, designed to provide comprehensive study of Venus's atmosphere, surface, and environmental dynamics. The project consisted of two main components, the Pioneer Venus Orbiter and the Pioneer Venus Multiprobe. The Pioneer Venus Orbiter was the first to arrive at Venus, entering orbit around the planet on December 4, 1978. Its primary mission was to map the surface of Venus using radar, as the planet's thick clouds made optical imaging impossible. Over its extended mission, the orbiter produced detailed radar maps that revealed the surface features of Venus for the first time. These maps showed a planet dominated by volcanic plains, with large highland regions and numerous impact craters. The data indicated that Venus had undergone extensive volcanic resurfacing, suggesting a geologically active planet. The orbiter also conducted extensive studies of Venus's atmosphere, including its composition, thermal structure, and dynamics. One of the key discoveries was the confirmation of the superrotation of Venus's atmosphere, where the upper atmosphere circulates the planet much faster than the planet itself rotates. This phenomenon, unique to Venus, intrigued scientists and has since become a major area of study in planetary science. The second component of the mission, the Pioneer Venus Multiprobe, was equally ambitious. This mission involved sending 4 small probes into Venus's atmosphere to measure its composition, pressure, and temperature at various altitudes. These probes, 3 small probes and 1 larger descent probe, were released at different locations and altitudes in Venus's atmosphere. They provided a wealth of data on the structure and dynamics of the atmosphere, including the discovery of high concentrations of sulfuric acid in the clouds, which were responsible for the planet's dense and reflective cloud cover. The data from the Pioneer Venus Multiprobe confirmed the harshness of Venus's environment. The probes measured surface temperatures around 460 degrees Celsius and pressures over 90 times that of Earth. Despite the extreme conditions, the probes were able to transmit data until they were eventually destroyed by the intense heat and pressure near the surface. The Pioneer Venus project was a resounding success, providing a comprehensive understanding of Venus that far surpassed previous missions. The radar maps produced by the orbiter have been crucial in studying Venus's geology, while the atmospheric data from the multiprobe have informed our understanding of planetary atmospheres more broadly. Pioneer Venus also demonstrated the value of using multiple probes and instruments to study different aspects of a planet, a strategy that has been employed in many subsequent missions. The Mariner and Pioneer missions to Venus were groundbreaking achievements in planetary exploration. They transformed Venus from a mysterious object shrouded in speculation into a well-studied planet with a complex and challenging environment. These missions provided the first clear evidence of the extreme conditions on Venus, including its high temperatures, dense atmosphere, and lack of a significant magnetic field. The success of these missions also had a profound impact on the field of planetary science. The data collected by the Mariner and Pioneer missions laid the foundation of our understanding of Venus and informed the design of future missions to other planets. The techniques developed for these missions, such as radar mapping and atmospheric probes, have been used in numerous subsequent missions, including those to Mars, Titan, and beyond. Moreover, The Mariner and Pioneer missions demonstrated the importance of international cooperation and competition in space exploration. While the United States and the Soviet Union were often rivals in the space race, their parallel efforts to explore Venus contributed to a richer and more nuanced understanding of the planet. The data from these missions have been shared and analyzed by scientists around the world, advancing our collective knowledge of the solar system. In the broader context of space exploration, the Mariner and Pioneer missions to Venus were a testament to human ingenuity and the spirit of discovery. They pushed the boundaries of what was possible at the time and set new standards for scientific exploration. The legacy of these missions continues to influence planetary science today, as we build on the knowledge they provided to explore not just Venus, but the entire solar system. One of the most significant milestones in Venus exploration was the Magellan mission, launched by NASA in 1989. Magellan was a radar mapping mission designed to penetrate Venus's thick clouds and provide high-resolution images of the surface. Over its 4-year mission, Magellan mapped nearly 98% of Venus's surface, revealing a world dominated by volcanic plains, towering mountains, and vast lava flows. Magellan's data transformed our understanding of Venus's geology. It showed us that the planet had experienced widespread volcanic activity and that its surface was relatively young, suggesting that it had been resurfaced by lava flows within the last few 100 million years. The mission also revealed features such as coronae, large circular structures thought to be formed by upwellings of molten rock, and tesserae, highly deformed regions that might represent some of the oldest terrain on Venus. Magellan's findings raised new questions about the history of Venus. For instance, why does Venus, which is so similar to Earth in size and composition, lack plate tectonics? What caused the planet's massive resurfacing, and why did it occur? These questions have driven much of the subsequent research into Venus and continue to be the focus of planetary scientists today. The launch of the Magellan spacecraft in 1989 marked a new chapter in the exploration of Venus, ushering in an era of detailed radar mapping that revolutionized our understanding of the planet. Magellan's mission was a pivotal moment in planetary science, providing unprecedented insights into Venus's surface and geology. This era of radar mapping built on previous missions' foundations, offering a detailed, comprehensive view of Venus that would inform scientific research and exploration for years to come. The Magellan spacecraft, named after the 16th century explorer Ferdinand Magellan, was designed to map the surface of Venus using synthetic aperture radar. This technology was crucial because Venus's thick atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid, obscured the planet's surface from optical observation. Radar mapping allowed scientists to penetrate these clouds and obtain a detailed view of the surface. Launched on May 4, 1989, aboard the Space Shuttle Atlantis, Magellan entered Venus's orbit on August 10, 1990. The spacecraft was equipped with a sophisticated radar system that could penetrate the dense cloud cover and map the surface with high resolution. Over the course of its mission, Magellan would become one of the most successful planetary exploration missions, providing a wealth of data about Venus's surface and geological features. Magellan's radar system operated at wavelengths that could pass through the thick Venusian clouds, allowing it to produce detailed images of the planet's surface. The radar was able to map 98% of Venus's surface during its mission, providing a comprehensive view of the planet that was previously unattainable. This detailed mapping revealed a planet with a highly dynamic surface, marked by vast volcanic plains, large impact craters, and complex tectonic features. One of the most significant discoveries made by Magellan was the confirmation of widespread volcanic activity on Venus. The radar images revealed numerous volcanic structures, including large shield volcanoes and lava plains. The data suggested that Venus was geologically active, with ongoing volcanic processes reshaping the planet's surface. Magellan also identified evidence of tectonic activity, including fault lines and deformed terrains, indicating that Venus's crust was undergoing significant stress and deformation. The Magellan mission also included detailed information on Venus's surface composition and topography. The radar data showed that Venus's surface was covered by a layer of volcanic rock, primarily basaltic in composition. The spacecraft's radar measurements also allowed scientists to determine the planet's surface elevation and identify large-scale geological features such as highland regions and impact basins. One of the key findings of the Magellan mission was the presence of a relatively young surface on Venus. The radar images indicated that much of the planet's surface had been resurfaced by volcanic activity within the last few 100 million years. This finding suggested that Venus had experienced a significant geological reshaping, which was likely driven by internal heat and volcanic processes. The mission also provided valuable data on Venus's atmospheric dynamics and interactions with the solar wind. Magellan's observations contributed to our understanding of Venus's superrotating atmosphere, where the upper atmosphere circulates much faster than the planet itself rotates. This phenomenon was revealed to be the result of complex interactions between Venus's atmosphere and the solar wind, influencing weather patterns and atmospheric circulation. The data returned by Magellan had a profound impact on the field of planetary science. The detailed radar maps of Venus's surface provided a wealth of information that was crucial for understanding the planet's geology and geological history. The mission's findings contributed to a broader understanding of planetary processes and volcanic activity, not just on Venus, but across the solar system. Magellan's success also demonstrated the effectiveness of radar mapping as a tool for planetary exploration. The mission's ability to penetrate thick atmospheres and provide high-resolution surface images set a new standard for future planetary missions. The techniques and technologies developed for Magellan have been applied to subsequent missions, including those to Mars, Titan, and other celestial bodies. The legacy of the Magellan mission extends beyond its immediate scientific contributions. The mission's success highlighted the importance of advanced technological capabilities in exploring distant planets and understanding their environments. The data from Magellan continues to be used in scientific research and analysis, providing insights into Venus's geology, atmospheric dynamics, and volcanic processes. Magellan also paved the way for future exploration of Venus. The mission's findings have informed the design of subsequent missions to Venus and other planets, influencing the development of new technologies and scientific approaches. The mission's success underscored the value of detailed planetary mapping and set the stage for ongoing exploration and study of Venus. Magellan's mission officially ended on October 12, 1994, when the spacecraft was deliberately deorbited into Venus's atmosphere. The decision to end the mission was based on the spacecraft's diminishing fuel reserves and the need to avoid potential contamination of Venus with any lingering Earth-originated bacteria. Despite its end, Magellan's data and contributions to planetary science remain highly valued. In the years since Magellan's mission, Venus has continued to be a subject of scientific interest and exploration. The detailed radar maps and data collected by Magellan have provided a foundation for ongoing research and analysis, contributing to our evolving understanding of Venus and its complex environment. New missions and studies continue to be built on the insights gained from Magellan, exploring new questions and challenges related to Venus's geology, atmosphere, and potential for future exploration. The Magellan mission stands as a testament to the advances in space exploration and the quest to understand our solar system's planets. Its legacy continues to inspire and inform planetary scientists as they seek to unravel the mysteries of Venus and explore the potential for future discoveries on this intriguing and enigmatic world. After the success of the Magellan mission, there was a lull in Venus exploration as attention shifted to other targets like Mars and the outer planets. However, the early 21st century has seen a renewed interest in Venus, driven by new questions about its geology, climate, and potential for past habitability. In 2005, the European Space Agency launched the Venus Express mission, which orbited Venus for over 8 years. The Venus Express provided detailed data on the planet's atmosphere, confirming the presence of a super-rotating atmosphere, where winds circulate the planet in just a few days, far faster than the planet's own rotation. More recently, in 2015, Japan's Akatsuki spacecraft successfully entered orbit around Venus after an initial failure. Akatsuki had been studying Venus's atmosphere in unprecedented detail, providing insights into the planet's complex weather patterns, including the mysterious Y-shaped cloud structure that spans the planet. Looking forward, NASA has announced 2 new missions to Venus, DAVINCI and VERITAS, both scheduled to be launched in the late 2020s. DAVINCI will focus on understanding the composition of Venus's atmosphere, potentially shedding light on how the planet evolved so differently from Earth. VERITAS, meanwhile, will use radar to map the planet's surface with even greater resolution than Magellan, aiming to uncover more about Venus's geological history and active processes. In recent years, Venus has experienced a resurgence of interest from the scientific community, driven by new discoveries and advances in technology that promise to unlock further secrets about the planet. This renewed focus on Venus reflects a broader trend in planetary exploration, as scientists seek to understand not only the history and current state of our neighboring planet, but also its potential for future exploration and study. Recent and ongoing missions to Venus represent a significant step forward in our quest to explore and comprehend this enigmatic world. One of the most anticipated recent missions to Venus is NASA's DAVINCI, Deep Atmospheric Venus Investigation of Noble Gases, Chemistry, and Imaging, Plus. Scheduled for launch in the late 2020s, DAVINCI aims to provide a detailed analysis of Venus's atmosphere and surface. The mission represents a significant advancement in our understanding of Venus's atmospheric condition and geological features. DAVINCI will include an atmospheric entry probe designed to descend through Venus's thick clouds and directly sample the atmosphere. The probe will carry a suite of scientific instruments to measure the concentrations of noble gases, such as argon and xenon, which can provide valuable insights into the planet's volcanic and atmospheric history. The mission will also analyze the chemical composition of Venus's atmosphere, focusing on key components such as carbon dioxide and sulfuric acid. One of the primary goals of DAVINCI is to improve our understanding of Venus's greenhouse effect and atmospheric dynamics. By studying the atmospheric composition and the interaction between gases and cloud particles, the mission aims to shed light on the processes that drive the extreme temperatures and pressure conditions on the planet's surface. This data will help scientists better understand the climatic history of Venus and how its atmosphere has evolved over time. In addition to atmospheric studies, DAVINCI will conduct detailed imaging of Venus's surface during its descent. The spacecraft will use high-resolution cameras to capture images of the planet's terrain, providing new insights into surface features and geological processes. These observations will complement the data obtained from previous missions and contribute to a more comprehensive understanding of Venus's geology and volcanic activity. The European Space Agency is also contributing to the renewed interest in Venus with its upcoming EnVision mission. Scheduled for launch in the late 2020s, EnVision will focus on studying Venus's surface and atmosphere with advanced remote sensing technology. EnVision will also carry a suite of scientific instruments designed to investigate the planet's surface, atmosphere, and volcanic activity. The mission will include a radar instrument to map the surface in high resolution, similar to Magellan's radar system, but with improved capabilities. This radar will allow scientists to analyze surface deformation, volcanic structures, and other geological features with unprecedented detail. Another key component of the EnVision mission is the atmospheric sounder, which will measure the composition and temperature of Venus's atmosphere. The sounder will provide data on the distribution of gases, such as carbon dioxide and sulfur dioxide, and their interactions with the planet's clouds. This information will help scientists understand the dynamics of Venus's atmosphere and its impact on the planet's climate. EnVision will also investigate the planet's ionosphere, which is the region of the atmosphere influenced by solar radiation and charged particles. Understanding the ionosphere is crucial for comprehending the interaction between Venus's atmosphere and the solar wind, as well as the influence on the planet's weather patterns. Overall, the EnVision mission aims to provide a comprehensive view of Venus's geological and atmospheric processes, building on the knowledge gained from previous missions and contributing to the ongoing exploration of the planet. Another significant upcoming mission is NASA's VERITAS mission, the Venus Emissivity, Radar Science, INSAR, Topography, and Spectroscopy mission, because they love their acronyms. Scheduled to launch in the late 2020s. VERITAS will focus on studying Venus's surface and geology using a combination of radar and spectroscopic instruments. VERITAS will carry a synthetic aperture radar to map the surface of Venus in high resolution. This radar will provide detailed information on the planet's topography, surface deformation, and volcanic features. By comparing radar data from VERITAS with previous missions, scientists will be able to track changes in Venus's surface and assess the ongoing geological processes. The mission will also include a spectrometer to analyze the surface composition and detect key minerals and volcanic gases. The spectrometer will provide valuable insights into the planet's volcanic history, including the types of volcanic rock present and the composition of volcanic emissions. One of the primary objectives of VERITAS is to investigate the planet's geological history and determine whether Venus has experienced significant tectonic or volcanic activity. The mission will also study the potential presence of past or present water on Venus, which could provide clues about the planet's climatic history and its potential for habitability. Japan's space agency, JAXA, has also expressed interest in exploring Venus. The Japanese mission Akatsuki, launched in 2010, is currently in orbit around Venus and continues to provide valuable data about the planet's atmosphere. Akatsuki's instruments are studying the dynamics of Venus's atmosphere, including its superrotation and cloud patterns. JAXA is also considering future missions to Venus, potentially including landers or atmospheric probes. These missions would aim to further investigate Venus's surface and atmospheric processes, contributing to the global effort to explore and understand this intriguing planet. The renewed interest in Venus is marked by a spirit of global collaboration and scientific curiosity. The upcoming missions from NASA, the ESA, JAXA, and other space agencies reflect the collective effort to explore Venus and address the unanswered questions about its geology, atmosphere, and potential for past or present habitability. These missions represent a new era of planetary exploration, driven by advances in technology and a growing understanding of Venus's significance in the broader context of planetary science. By building on the knowledge gained from previous missions and employing new technologies, scientists are poised to make groundbreaking discoveries about Venus and its complex environment. The future of Venus exploration holds great promise, with ongoing and planned missions set to provide deeper insights into the planet's history and processes. As we continue to explore Venus, we'll gain a more comprehensive understanding of its role in our solar system and its potential for future exploration and study. As we reflect on the history of Venus exploration, it's clear that we've come a long way from the early days of telescopic observations and speculative theories. Our understanding of Venus has evolved dramatically, revealing a planet that is as complex and dynamic as it is hostile. Yet, despite the challenges, the allure of Venus remains strong. The extreme conditions on Venus, while daunting, make it a fascinating target for future exploration and, potentially, for terraforming. Understanding Venus's climate and geology could provide critical insights into planetary science, helping us to build better understanding of Earth's own climate and a potential for habitability on other planets. Moreover, the technological advancements required to explore and possibly terraform Venus could have far-reaching implications, driving innovation in material science, energy generation, and environmental engineering. As our understanding of Venus deepens through ongoing missions and advanced technologies, the potential for future exploration and even terraforming of the planet continues to inspire and challenge scientists and visionaries alike. The future of Venus's exploration promises to unlock further secrets of this enigmatic world, while the concept of terraforming offers intriguing possibilities for terraforming Venus into a more habitable environment. The future of Venus exploration is set to benefit from rapid advancements in space exploration technology. As scientists and engineers develop more sophisticated instruments and spacecraft, the ability to study Venus in far greater detail will expand significantly. Upcoming missions, such as NASA's DAVINCI and VERITAS and the ESA's EnVision, are expected to provide a wealth of new data that will enhance our understanding of Venus's atmosphere, surface, and geological history. Future exploration missions could include innovative approaches such as high-altitude balloon probes or aerial drones. These platforms would allow for long-duration observations and measurements of Venus's atmosphere, providing continuous data collection and real-time analysis. Balloons or drones could explore different atmospheric layers or regions, offering insights into the dynamics of Venus's super-rotating atmosphere and its interactions with the solar wind. In addition to aerial exploration, there is growing interest in developing technologies for landing on Venus's surface. While the extreme conditions present significant challenges, advancements in material science and engineering could make it possible to design landers and rovers capable of withstanding the high temperatures and pressures. These landers could provide direct measurements of surface composition, geological features, and volcanic activity, offering a more comprehensive understanding of Venus's surface processes. The concept of human exploration of Venus, though still speculative, is an intriguing possibility for the future. The extreme environmental conditions present significant hurdles, but advancements in technology and materials could eventually make it feasible. Human missions to Venus could focus on studying its atmosphere, surface, and geological features up close, providing valuable insights that cannot be obtained through remote sensing alone. Human exploration could involve sending astronauts in specialized spacecraft designed to withstand the harsh conditions of Venus's atmosphere. These spacecraft would need to incorporate advanced thermal protection systems, radiation shielding, and life support technologies to ensure the safety and well-being of the crew. The development of such technologies would require significant research and testing, but the potential rewards of human exploration could be substantial. In addition to surface exploration, human missions to Venus could also include the establishment of temporary or permanent bases in the upper atmosphere. These bases could serve as research stations for studying atmospheric phenomena, conducting experiments, and testing technologies for future exploration. Floating platforms or cloud cities, although still a theoretical concept, could provide a unique vantage point for studying Venus's atmospheric dynamics and climate. The concept of terraforming Venus, transforming it into a more Earth-like environment, represents one of the most ambitious and speculative goals in planetary science. While the idea of terraforming Venus is still in the realm of science fiction, ongoing research and technological advancements are gradually bringing it into the realm of possibility. Terraforming Venus would require addressing several major challenges. The first and foremost challenge is the extreme greenhouse effect that causes Venus's surface temperatures to reach around 460 degrees Celsius. To achieve a more temperate climate, it would be necessary to significantly reduce the concentration of greenhouse gases, particularly carbon dioxide, in the planet's atmosphere. This could potentially be accomplished through processes such as carbon capture and storage, or chemical reactions that convert carbon dioxide into other compounds. Another critical challenge is Venus's high atmospheric pressure, which is about 90 times that of Earth's atmosphere. Reducing the atmospheric pressure would be necessary to create a more hospitable environment. This could involve removing a significant portion of the planet's atmospheric gases, or employing technologies that manage pressure levels. The concept of introducing water to Venus is also a key component of terraforming efforts. Water is essential for life as we know it, and its presence would be crucial for creating a habitable environment. Methods for introducing water to Venus could include delivering ice or water-rich materials to the planet or utilizing chemical reactions to produce water from existing atmospheric compounds. Additionally, the idea of altering Venus's surface features to support life is a complex and ambitious goal. This could involve creating stable landforms, managing volcanic activity, and developing ecosystems that can thrive in the new environmental conditions. Advances in biotechnology and genetic engineering may play a role in developing organisms capable of surviving and thriving in the altered environment. The prospect of terraforming Venus raises several ethical and practical considerations. The impact on potential native environments, the sustainability of such efforts, and the long-term consequences for the planet's climate and geology must be carefully evaluated. The concept of terraforming raises questions about our responsibilities as stewards of other worlds and the potential consequences of altering planetary environments on a large scale. In addition to the ethical considerations, the practical challenges of terraforming Venus are immense. The scale of the required technological and engineering efforts, the costs involved, and the need for international collaboration are significant factors that must be addressed. The development of technologies for terraforming would require breakthroughs in multiple fields, including material science, environmental engineering, and planetary science. As we look to the future, the exploration and potential terraforming of Venus represent exciting and challenging frontiers in planetary science. The ongoing and upcoming missions to Venus will provide crucial data that will shape our understanding of the planet and inform future exploration efforts. Advances in technology, combined with scientific research and international collaboration, will play a key role in the advancing of our knowledge and capabilities. While terraforming Venus remains a distant goal, the pursuit of this vision drives innovation and inspires new research. The quest to explore and understand Venus not only enhances our knowledge of our solar system, but also pushes the boundaries of human ingenuity and exploration. As we continue to study Venus and develop new technologies, the possibilities for the future of Venus exploration and terraforming will continue to evolve, offering new insights and opportunities for discovery. As we conclude this third installment in our series on terraforming Venus, it's clear that the exploration of this enigmatic planet has been a journey of remarkable discovery, perseverance, and innovation. From the earliest observations by ancient astronomers to the sophisticated missions of the space age and beyond, our quest to understand Venus has continuously pushed the boundaries of what is possible in planetary science. The story of Venus exploration is one of both triumph and challenge. The early missions, spearheaded by the Soviet Union and the United States, laid the groundwork for all that followed, proving that even a planet as hostile as Venus could be reached and studied. The Venera landers, with their brief but groundbreaking transmissions from the planet's surface, and NASA's Mariner and Pioneer missions, which provided the first detailed images and atmospheric data, were monumental achievements that deepened our understanding of Venus as a world of intense heat, crushing pressure, and volcanic activity. The Magellan mission, with its radar mapping of the planet's surface, represented a leap forward in our ability to visualize and analyze Venus's complex geology. The detailed maps and data generated by Magellan gave scientists new insights into the planet's volcanic plains, mountain ranges, and tectonic features, challenging our understanding of planetary formation and evolution. In recent years, we've seen a resurgence of interest in Venus, fueled by new technological advancements and intriguing discoveries. Missions like NASA's upcoming DAVINCI and VERITAS, along with ESA's EnVision, promise to revolutionize our understanding of Venus's atmosphere, surface, and geological history. These missions are not just about studying Venus as it is today. They're about answering fundamental questions about the planet's past, its potential for hosting life, and its future as a target for human exploration. As we reflect on the history of Venus's exploration, it's important to recognize that each mission has been a stepping stone, building upon the knowledge and achievements from those that came before. The data gathered from these missions has not only expanded our understanding of Venus, but has also provided valuable lessons for exploring other planets and moons in our solar system. Looking ahead, the exploration of Venus is far from over. With new missions on the horizon and the potential for future manned exploration, Venus remains a vital subject for scientific inquiry. The challenges of exploring and possibly terraforming Venus are immense, but so are the possibilities. Each new mission brings us closer to unlocking the secrets of this neighboring world and understanding the complex dynamics that have shaped its environment. In this video, we've journeyed through the centuries of Venus exploration, from ancient observations to the cutting-edge missions of today. As we continue to explore Venus, we do so with the knowledge that our efforts are part of a larger narrative, a narrative that stretches from the past through the present and into the future of planetary science and exploration. The story of Venus is still being written, and as we move forward, we remain driven by the same curiosity and determination that has guided humanity's exploration of the cosmos for generations. As we look to the future, the history of Venus's exploration serves as both a cautionary tale and a source of inspiration. It reminds us of the challenges that lie ahead, but also the incredible progress we have made in our quest to understand the universe. With new missions on the horizon and a growing interest in Venus's potential, the story of Venus exploration is far from over. Instead, it's entering an exciting new chapter, one that could ultimately lead to the transformation of Venus into a world that is not only explored, but also inhabited by humans. The exploration of Venus has always been a story of pushing the limits of what's possible, of overcoming extreme challenges, and of expanding our knowledge of the cosmos. As we continue this journey, we can be sure that Venus will remain a key focus of our quest to explore and perhaps one day inhabit the solar system. Thanks for tuning in. I hope you found this video informative and thought-provoking. This is the point where others tell you, if you enjoyed it, please give it a thumbs up and consider subscribing for more content just like this. But we know that kind of thing is for losers. Don't be a loser. And as always, I value your comments and ideas for future videos in the comments section below. Until next time, keep exploring, keep learning, and keep embracing your inner nude, dude.